moving rod also you can send towards a particle. This is a particle. I think the whole system lies where on the smooth horizontal surface. And during collision, what conditions will arise? The particle will be in contact with the rod, so an impulse will act here, and an impulse will also act on this. And this is the what do you expect now after collision? After collision, because of the impulse acting, will it acquire any angular velocity? I'll give one more diagram. No, after collision, the ball what will happen? Let it be rebound with a speed v2, and that now the center of mass of the rod v1. How we should read it? I have to look at the impulse g. Impulse g. Look at the impulse g. How it like anti-clockwise. So therefore, I'm going to put the angular velocity in this direction. And after rebound, there's a condition. So what we have to find out that v2, v1, and omega 1. So how do you can firmly say that the rod must rotate anti-clockwise? Because look at the impulse g, how do it act? It will act anti-clockwise. So therefore, there should be angular impulse. There should be angular momentum for the rod due to rotation motion about O anti-clockwise. So therefore, angular velocity will be anti-clockwise. So rest all what we have to do, we have to find out V2, V1, omega 1. Can you apply conservation of linear term? Look at the net impulse acting on system is 0. So from that, first equations will be conservation of linear momentum. This should be equal to what? Initial momentum is equal to final momentum. No, initial momentum. Initial momentum. What is initial momentum? 4m 2u minus mu should be equal to finally 4mv1 plus mv2. Or solving this, 8u minus 7u is equal to 4v1 plus v2. This is equation 1. What else? Any other equation? Applying conservation of angular. About what point you are going to apply it here? About any point of the rod? Yes, about any point. But about what point the rod is rotating? About its own center. So therefore, let's apply conservation of angular term about an axis passing through O and perpendicular to plane. So initial angular momentum, mu L anti-clockwise. But sir, there is a momentum also for the rod. The 2u will intersect axis of rotation. This 2u will be intersect axis of rotation. What is the axis? This axis passing through perpendicular to plane. So mu. So what is the distance will be L by 4. It will be like this. So mu L by 4 anti-clockwise. Final momentum. Angular momentum of the rod I naught omega 1 anti-clockwise. Due to translative motion of the rod, because V1 will intersect axis of rotation. So this axis is passing through point of perpendicular plane. V1 will intersect. So angular momentum due to translative motion will be 0. Angular momentum due to translative motion of the particle. So what is the distance here? This will be L by 4. So therefore this will become M.
Sir, it will be L, sir.
This is L, no? 4L we took it, no? Yeah, fine. Anything, this you take it to be positive. So 4m 4l square by 12, this will be positive, whereas this will be negative. mv2l. So this is equation 2. We need one more equation. What is one more equation? Three unknowns are there. We need one more equation. Quotient of restitution. So let me take this as line of impact, and anything directed towards right, let me take it positive. Then quotient of restitution is equal to velocity of the particle v2 velocity of particle v2 minus this is positive, no? Velocity of point P. I'm assuming it to be positive. I'll solve it. Then velocity of particle minus velocity of initial velocity of the rod. Please do look at the sign. These are very important. Velocity of the particle, I'm taking the second object, v2 minus v1 by u1 minus u2. No, u1 will become the rod, u2 will become the particle, and anything directed towards right will be positive. So we don't know vp. What should be the vp? v1 minus l omega 1. L omega 1 will be towards left. Tangential velocity. V1 will be towards right. So V1 minus L. Sir, I'll solve it. I'll get negative. Okay, let it be. It'll be negative. So don't put here anything sign. The sign for VP will come from solving this. So just leave it. VP I'm assuming towards positive. I'll solve it. Then like a V1 V1 if I get negative. Negative means what you assumed is opposite. Sir, V2 I'll get positive. Then what you assumed is correct. If you get V2 negative, then you should change the sign. Solving 1, 2, 3 will get the required answer. So even the rod need not be attached. Rod and particle both can be moving. There's a very popular, everyone must solve some selected numericals. You must work out different types of numericals. Almost maximum discussing, still you have to work out few more. Is there any loss in energy? Yes. Where do that energy gone? Rod is a rigid, no? Rod is a rigid. So yeah. So rod is a rigid. So then particle. So where do that energy gone? So let's say that heat.